Hi guys, we're on Unit 3, Day 8, and this is called Inverse of a Function. So it says inverse of a function, xy. The inverse would be yx. So all an inverse does is switch the x and the y, or switch the output and the input, or switch the domain and the range. And when you do with the points on all the points on a function, or some points on a function, you don't have to do all of them. Obviously, there's infinitely. And you switch their coordinates around and you graph those coordinates, you get a picture that looks like this. Whereas this one here may be considered the original. And when you take all the coordinates on it, or a bunch of them, and you switch the y and the x, and then you graph those points with the y and the x switched, you're going to get something like this. And some mathematician did this back in the day with a whole lot of functions, and found every single time that is a reflection over the line called y equals x. And so you actually graphed these in geometry when you were asked to reflect over the line y equals x, and you counted diagonally to the line, and then you counted diagonally the same amount over the line. You were actually graphing an inverse. And so that's what an inverse is looking like graphically, and with the switching of the coordinates. Okay. And so here we go. So we're going to literally say the idea of inverses is very important in math. Two functions are inverses because they literally undo each other. Okay. To find an inverse of a function, you simply swap the x and the y values. Okay. And then if it isn't an equation, once you switch or swap x and y, then you have to put it back into y equals form. Okay. Inverse notation, this is what we're used to, f of x, but its inverse would be written as that. And we've seen this little -1 when we did sine and cosine and tangent to the little -1 when we were solving for an angle back in geometry. Okay. So we're going to head down and see what these questions are asking us about inverses. Okay. So it says if the point -3, 5 lies on the graph of f of x, then which of the following points must lie on the graph of its inverse? So inverse is our key word. And so we have to remember that every time we see inverse, all we have to do is switch the x and y. And so they gave us an x and a y up here. -3 is our x and 5 is our y. And if we switch them, we end up with the point 5 being first instead of second, and -3 being second instead of first. And so that point would be on the inverse, and the coordinates match those in choice 2. Okay. All right, so notice we didn't change any signs or anything. A lot of people think inverse with the little -1, they want to change the sign. Nope, it just changes the position of the x and the y in the coordinate. Okay. Number 2, it says given the function g of x equals 5x minus 8, which point below would be on g inverse of x? Okay. Okay, so what we can do is that because we need a point instead of the equation, we're going to put the equation in our y equals in our calculator. So go to y equals, okay, put in 5x minus 8, and then we're going to hit second graph. And now those are all the points. So in the first one, it was easy because they gave us a point. In the second one, they took the point away, but they gave us an equation, which we can get the points from our calculator. So if we go ahead and we look for 0, -8, we're going to realize that 0, -8 is on g of x. So on g inverse of x, okay, would be the point -8, 0. And that's not an option. So we can go to the next point. We could look at 7, 3. We don't see 7, 3. We see 7, 27. Okay, so 7, 27 is on g of x. Therefore, 27, 7 would be on g inverse of x. So you can see that that's not looking good. Okay, but if we go to 3, 7, okay, 3, 7 is on g of x. And therefore, 7, 3 would be on the inverse. And so we're going to go ahead and pick number 2, since 3, 7 is on g of x. Okay, 7, 3 would be on the inverse of g of x. Okay, all right, so we'll head to the next one. In number 3, it says the function y equals h of x is graphed below. Create a table for values of h inverse of x, okay? And then sketch a graph of the inverse. Okay. So what we're going to do is we're going to go and steal the coordinates. So instead of them giving me a point, that's the easiest. Instead of giving me an equation where I can get the points in my calculator, that's the second easiest. They could give me a graph of the points already plotted. And so, but now I got to go and yank those coordinates off of there and see what they are. So let's see, that's -1, 2, 3, 4, 5. So this is -5, comma, 1, 2, 3, -4. Okay, this next point would be -4 and -3. This point here is at -1, -2. And then this point on the right-hand side is 1, 2, 3, 4, -1. Okay, so in order to create our table of values, not for h of x, but the inverse of h of x, we're going to take all those coordinates and we're going to go ahead and put all the x coordinates in the y spot. Weird, right? So in the y spot, we're going to have -5 because we're switching them. Okay. And therefore, -5 goes with -4. So -4 would then become the x. Okay. -5 was an x. Now he's a y. Okay. In the inverse. And the same with the next point. So the x coordinate of -4 is now going to become a y coordinate of -4. The -3, which was a y coordinate, is now becoming an x coordinate that goes with it. Okay. -1 was an x, so now it's a y. -2 was a y, and now it's an x. Okay. And then the last one, 4 goes in the y spot, and -1 goes in the x spot. Okay. And now we're going to go ahead and graph those and see what they give us. So we're going to go ahead and graph the point -4. 1, 2, 3, 4. -5. 1, 2, 3, 4, 5. Okay. Then we're going to go ahead and graph -3. 1, 2, 3. -4. 1, 2, 3, 4. Okay. Then we're going to go ahead and graph -2. -1. And then we're going to go ahead and graph -1, +4. 1, 2, 3, 4. Okay. And then we're going to go ahead and graph a nice smooth curve in between them. Okay. And if you notice, and I wish I had a straight edge on here, but this is that line y equals x. Okay. And that original graph reflected over that line y equals x would become that blue one that we just graphed. Okay. And so those are inverses of each other. Okay. Part B says state the domain and range in interval notation for the original one graphed. So we're going to go ahead and say domain, and we'll just use set notation or interval notation because that's a little bit easier. Set notation is a little bit trickier. Okay. And it looks like our furthest to the left x value seems to be -5. And on that graph that was already graphed for us, the furthest to the right x value looks like it's at 4. And those are closed circles, so we will include them. Okay, no arrows and no open circles. For our range, it seems that the lowest we go, lowest y value on the one that was already graphed for us was -4. And the highest y value on the one that was already graphed for us was -1. And again, those are going to be included. Okay. And then part C says to state the domain and the range in interval notation for the inverse. So now we're going to do the same thing, but we're going to do it for the inverse. Okay. So the domain on the one that we graphed in blue, the furthest to the left it goes is -4. And the highest the one we graphed goes is 1, 2, 3, 4. Oh, I'm sorry. Furthest to the right it goes. I was going high before to the right. Domain is your x value, so I almost swapped out a y value for it, so be careful. Even I do it. So the furthest to the right this graph goes is -1. And those are included. And then for our range of the one we graphed in blue, the lowest it goes is 1, 2, 3, 4, 5, -5. And the highest it goes, which I almost did just a second ago, is positive 4. And those are going to also be included. And I don't know if you notice, but remember that in an inverse, not only does x and y switch, or the input and the output switch, but because the x's are the domain and the y's are the range, the domain and the range switch. So I could have been done with this a long time ago, okay, had I realized that it's just a switching of the domain and the range for the inverses. Okay. Part D says, what do you notice about the answers to part B and C? And we're just going to go ahead and say that the domain and range switch as well as x and y. The domain, which is our x, and range, which is our y, switch in inverses. Okay. Part E says, is that a function? Is the inverse one a function? I don't know. Does it pass the vertical line test? And so looking at that one that we graphed in blue, it does pass the vertical line test. And so we go ahead and say yes, passes vertical line test. And then it says, how can this be predicted? So this is a little bit tricky to think about, but if the original one, and we'll write this down as we talk about it, if the original h of x passes what they call a horizontal line test, when the x's and y's switch, the inverse, or h inverse of x, will pass vertical line test. Okay. And passing the vertical line test means that you become a function, or that you are a function. Okay. So a quick way to know if the inverse will be a function is to apply the horizontal line test to the original graph. Okay. So that when they switch, you can see that no x values will repeat if you check for the y values on the original. So a little bit tricky to understand that. Okay. We're going to go ahead and to the back side of our notes, and I'll see you guys there.